Hello everyone, in this video we're going to be proving an inequality. X and y are positive real numbers such that x plus y is equal to 1, and we're supposed to prove that the quantity 1 plus 1 over x times 1 plus 1 over y is greater than or equal to 9. Before we start the proof, let's go ahead and explore this a little bit. Now x plus y needs to be 1 and they're both positive. So this basically means that x and y are actually bounded, right? X and y needs to be greater than 0, and at the same time, their sum is 1, so they need to be less than 1 as well. And since they can't be 0, none of them can be 1 either. So let's take a look at a couple situations here. For example, what happens if x is equal to 1/3 and y is equal to 2/3? Let's go ahead and plug it in and see what happens. Well, the reciprocal of 1/3 is 3, so it's going to give you 1 plus 3, which is 4. And then 1 plus 1 over y is going to give you 1 plus 3/2. This is going to be 4. This is going to be 5/2, right? And their product is going to be 10. So we're getting the value of 10 here. I mean, this is by no means a proof, but it just shows you that value of 10 is attainable. But I think the more critical part here is going to be, is 9 attainable, right? Because we're claiming that the minimum value for this expression is 9. It could be greater. Is 9 attainable? Let's take a look. Well, since x and y are symmetrical here, why don't we just set them equal to each other? What happens if x equals y? Then we get x equals y equals 1/2. Now in that case, 1/2, the reciprocal of 1/2 is going to be, 2. So we get 1 plus 2 multiplied by 1 plus 2, which is equal to 3 times 3, which is equal to 9. So 9 is attainable if x and y are equal, and that makes sense because when x increases, y needs to decrease, so on and so forth. Okay, so let's go ahead and talk about the proof of this inequality. Now, what are we going to do? Well, there's a couple ways to do it, and you can definitely share that in the comment section, but I'll just be presenting one method here. And if you have a different idea, please share with us and, just contribute. So what am I going to do? Well, I have that x plus y is equal to 1. And I need to prove this. So why don't I just go ahead and take this product and break it down? Or should I say distribute? Let's go ahead and distribute that and see what happens. When I distribute this, I'm going to be getting something like this, right? I'm going to get 1 plus 1 over x plus 1 over y, and then when I multiply 1 over x times 1 over y, I should be getting 1 over xy. Great. Now you might be thinking about making a common denominator, and what happens if you do make one? Well, it's going to be xy, so you're gonna be getting something like, if you make a common denominator, I'm just saying, you'll be getting xy plus x plus y plus 1, and then all over xy. And the top part, as you know from Simon, is factorable. And you can write it as x plus 1, y plus 1, and then divided by xy. Now, the only thing we know is that x plus y is equal to 1, and we weren't able to use it here. And you don't really know anything about this product, x plus 1 times y plus 1. So let's go ahead and not distribute the whole thing or not make a common denominator, but let's make it in a smarter way. For example, if I take these two expressions and put them together, I'll be getting something nice. Because this gives you 1 plus x plus y over xy plus 1 over xy. So it's better not to make a common denominator for the whole thing. Well, we do know that x plus y is equal to 1, right? So we can just go ahead and replace x plus y with 1, and that gives me 1 plus 1 over xy plus 1 over xy. And as you know, this is equal to 1 plus 2 over xy. So what am I trying to do? I'm trying to prove that this expression here, which comes from, 1 plus 1 over x times 1 plus 1 over y, that's how I got this, right? I'm trying to prove that this is greater than or equal to 9. So my expression here, right here, is obviously much better than the original one, and I need to prove that this is equal to greater than or equal to 9. So is that true or false, right? That's what I'm trying to do. Well, in this case, since they asked us to prove it, that must be true, right? Okay, so I'm getting the expression xy here. So I started off with something like x plus y is equal to 1, and now I need to look at xy. So how are they related? Well, again, there are many ways to look at it, but the method that I picked today for you is going to involve the following. And this is kind of nice because this involves an identity that we've been using in our problems, especially the geometry puzzles that we haven't done for a long time, by the way. We use these identity all the time. And algebraically, this is a really cool identity. I think it's very helpful for solving many problems. But anyways, this is what it is. X plus y quantity squared minus x minus y quantity squared is equal to 4xy. As you know, this is very helpful because it allows you to directly relate the square of the sum and the square of the difference. That's what I'm going to use today. So what is that supposed to mean? Well, this identity holds for xy real numbers. So, and I know that x plus y is equal to 1 right there, right? So let's go ahead and replace x plus y with 1. And this gives us 1 minus the quantity x minus y squared is equal to 4xy. Okay, great. Now, how am I going to use this inequality? Well, notice that in my expression here, I'm trying to prove that this is greater or equal to 9. So I have the expression xy. And I have the expression xy here as well. So that's helpful. But what am I going to do with the x minus y quantity squared, right? Well, remember that that's a non-negative quantity. So what is that supposed to mean? Well, it means that this expression right here is going to be less than or equal to 1 because you're subtracting a non-negative number from 1. And so the answer is either going to be 1 or less than 1 because you're basically decreasing it if x minus y does not equal 0. Okay, so we can safely say that 1 minus the quantity x minus y squared is less than or equal to 1, which means that 4xy, because it's equal to that, is less than or equal to 1, which means xy is less than or equal to 1/4. Beautiful. This is what I needed because I'm going to prove that this is true. And of course, that comes from my original problem, which means that everything looks good. And by the way, these are two-sided implications because x and y are positive, so it's all good. Okay. Yeah, we always got to remember that, by the way, because if you divide by a negative number, the inequality changes, so on and so forth. Anyways, so the question now is, how can I go from this to this one? 1 plus 2 over x plus y. Okay, so this is what I'm trying to get at. In other words, if this is true, then what does this become? Okay, here's what we can do. Since x and y are both positive, I can just go ahead and reverse the process. If xy is less than or equal to 1/4, this implies that 1 over xy is greater than or equal to 4. Great. Because we can just, use the reciprocals, right? And then I do need 2 times this. So let's go ahead and multiply both sides by 2, which is a positive number. This implies that 2 over xy is greater or equal to 8. And notice that I only need to add 1 to both sides. And if I do, I get 1 plus 2 over xy is greater than or equal to 9. By the way, let me just tell you that this is not just like an implication. We're not just trying to go backwards, but notice that 1 plus 2 over xy, so I should probably write it this way. My original expression was 1 plus 1 over x, I just couldn't say it. 1 plus 1 over x times 1 plus 1 over y. And we found that this is equal to 1 plus 2 over xy. And we just found out that this is greater than or equal to 9. Which implies that my original expression is greater than or equal to 9. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.